So first off, after watching that video on the ocean currents, is there any questions that you guys have that you would like me to answer that didn't quite make sense in the video? No? Are we okay? All right, so the main reason why I wanted you guys to watch that video is because when you guys are talking about plastics in the ocean where it's accumulating in the trash island, you need to understand why it's occurred. And so in order to understand why it's occurred, we're looking at the ocean currents and how that's going to move around basically trash. So trash that comes from the United States, how it can move and end up in Japan and things like that, and why it kind of accumulates in places like the Pacific as well. So the main thing we got to keep in mind when we're looking at this is that there are things called ocean currents, and it's just basically about how the water is moving. Water moving around the ocean is actually quite a complex process because there's multiple layers that are going to cause that water to move. The first layer of why water moves in the ocean has to do with the wind that's blowing and physically kind of pulling it and making those waves. And you have to also remember, like the video was saying, that there are multiple layers when it comes to the ocean as well. So like when we have the wind blowing at the top, that's obviously going to affect the top layer of the ocean most and kind of causing it to move and then creating those waves that we see. But because these higher layers are also moving, it's going to drag some of the lower layer beneath it. And then again, because these guys are moving and dragging, it's going to drag some more of the bottom layer. So all of the ocean has water that's moving. It's not just the top layer, and it's not moving all consistently either. So that's something else to keep in mind. The other thing that's going to be a factor in how the water is going to move is the, I think it's topography. I don't know if I'm saying that right, but it's basically the ocean floor and what structure it has underneath it. Like, does it have underwater mountains? Does it have like huge valleys? Like all of those things are going to influence then how the water moves as well. So that's something to kind of keep in mind when we're looking at it. So that's kind of the first layer to why the water's moving around. The second layer to why it has to do with tides. Do you guys know how the tide works? Kind of. Okay, should I explain it? Yeah. Okay. So we have the planet Earth, and then we have water that's basically around most of the Earth like that. Oh, that's not a very even circle, but that was kind of the idea to start off with. Now, the thing to remember about the Earth and its water is that it's not all at the same level at the same time, because what happens is we have the sun. I should have centered that more. I'm not happy with that. Let me set my last piece of paper. We're just going to cross that out and start over. I don't like where that is. All right, so we have the Earth, and then we have the water on the Earth, like that. Now, there are two big, not even big, there's two gravitational bodies that pull on the Earth. The first one is the sun. So it has gravity, and it's going to pull stuff towards it. The other thing that we have is going to be the moon. Moon's smaller, but it's closer. So even though it's not as big as the sun, because it's closer, it's going to pull basically at a similar kind of gravitational pull on it. The sun's further away, but it's bigger, but it's still being able to pull. It will pull on the Earth. The main thing, though, is that it pulls on the land and it pulls on the ground, and it stretches the Earth into like a more like an oval shape. But obviously, water is going to be more affected by it than the land. So what happens is that we're going to get bulges of water when that section of the Earth is next to the moon or next to the sun. Are we okay with that so far? So as the Earth rotates, it's going to rotate in and out of these bulges, and that's why we have low and high tide. So the Earth is going to be rotating around, and as it rotates around, it goes into the section where the bulge is occurring because it's right next to the moon. And then when it rotates to this middle section here, there's going to be a low tide. So when we're here, it's low. When we're over here, it's high tide. So it causes it in 24 hours. So we have our first, like if we're here initially. No, there was a mistake on the relief.
Oh, so no relief.
Yeah.
Oh,
It's okay. Yeah. All right.
Yeah, that's a possible.
Yeah.
What?
His outfit.
I thought it was Peppa Pig.
No, but the whiskers.
Oh. Wait, was he the Pink Panther? Oh, I thought he was Peppa Pig.
No, it was the whiskers.
Okay. Okay. All right. So let's say we're in New Zealand and we're right here. So right now we are going to be in a low tide, and so when you have a low tide at the beach, you see a lot of beach land, and the water's really far away, and you have to walk a long way to go to swim. But as the Earth rotates, it's going to rotate in this area where the water is bulging because it's being pulled towards the moon, and then we get high tide. And so when you go to the beach, the water's going to be very inland. And then another 6 hours later, we're going to be on the other side, and we're going to be in a low tide again, so the water goes back out. And then we rotate some more. We're then in this position here. We're going to be in a high tide. So that's going to make the water come back in. So that's why we have 2 high tides a day and 2 low tides a day. And that's why you got to be careful when you park your car on the beach. Because if you park your car on a low tide time, the water's going to come in, and your car's going to be underwater. Does that make sense? And if you ever get into like water sports, you get very mindful of looking at the tides and the weather, because you might want to go out surfing during the high tide, so you have bigger waves, stuff like that. Does that make sense? Okay. And then the last thing to think about when it comes to the movement of the water is going to be the temperature. You know how like hot air balloons rise in the air because it's hot air? So hot air rises because it's less dense, because the particles are further away. So same thing with water. So when water is hot, like here where the equator is, it's going to start to rise up to the colder parts because it's less dense. And then when it gets cold in the northern and southern parts of the globe, it's going to become more dense and start to sink downward. And that's what causes those gyres, those like circulations and with the water. You also have the same thing happening at the different levels of the ocean as well, because the water up here is going to be warmer than the water down here, and so you have the same convection currents happening here as well. So the main thing to kind of keep in mind with all of this is that the water's moving. And with those plastics that originate from the US travel to other parts of the world and vice versa, and they tend to then accumulate in these whirlpools on our planet, making our little trash islands. If you look at the sources that I provided today, trash or garbage island or garbage patch isn't actually an accurate term for what it actually looks like. You'll watch the videos and it'll explain it, but the main thing about the trash islands is that it's not like a physical island that you can go onto that is garbage. It's all the little microplastics. So it's like the plastic that's been broken up into small little pieces. So, and then the problem is the fish eat that, and then the bigger fish eats that, and then it gets in our food chain, and now we're eating all these microplastics. So like even humans are eating plastics and stuff. So those videos are good to kind of get an idea of that. The other thing that's interesting about the plastics in the ocean is that we only know where 10% of the plastic is. So we can see like 10% of the iceberg is what they describe, and then the rest of the plastic is actually quite dense, so it's sinking, and it's at the ocean floor level instead. Depends on where you are in the ocean, but very, very deep. Yeah. So that's what you guys are looking at when it comes to the standard and the validity of sources. Like, are they oversimplifying it by calling it the garbage island or garbage patch? What does it actually look like? So those sources that I put on there are actually really good because it does talk about the plastic on there. So there's like 3 videos there, and I've also linked to his website talking about plastic soup, because describing it as plastic soup is probably a better way to describe it because it's all the little microplastics. So yeah, that's basically it. That should cover all the content I need to go through with you guys.
Oh, at least he's been.
Just missed the whole talk. You're gonna have to catch him up. The door was open. I unlocked it. Just trying to avoid work. All right. So that should cover enough content teaching for you guys to be able to read all the sources and watch all the videos and have a basic idea of like what plastics are, what validity of sources means, and the ocean currents. I don't have any more lessons planned for you guys regarding this because it is a research-based internal, but if you guys have questions, feel free to ask me, or if you want me to kind of clarify something that you see in the video. Okay? That's mostly it, and you guys are going to probably feel real depressed at the end of this because it's really sad when you think about all the plastics that are in our oceans. Well, I'll give that to you. I have recorded it, but the recording's probably not going to go up until later today.
Thank you so much.
Your friends are looking out for you.